Hello, this is my first time in South Korea, so it's wonderful to be here. I want to talk today about a military strategy technique called the OODA loop. Has anyone heard of the OODA loop before? Okay, it was invented by a US Air Force officer called John Boyd. And OODA stands for Observe, Orientate, Decide, and Act. So if you're in some kind of military conflict situation, the idea is that you observe your current situation, you orientate yourself by looking at your surroundings, seeing what the enemy is up to. You make a decision on what to do, you take some action, and then you start again. After the action is complete, you see where you are, and you see where your enemy is. And you carry on around the OODA loop. And if that sounds familiar, it's because it's very much what we see in Kubernetes with the reconciliation loop, where a controller will look at the current state, look at the desired state, identify what the difference is between the two, and create or destroy resources to bring the current state in line with the desired state. And if we were talking about a deployment, we might look at the number of pods, look at how many replicas we were expecting, decide whether there's too many or too few, and then the controller will create and destroy pods as necessary. So let's take a look at that happening. I've got a very simple Nginx deployment that expects to have 3 replicas, a replica count of 3. And you can see there are 3 pods running Nginx right now. So if I delete one of those pods, that controller is going to spot that a pod is terminating, and it will immediately create a new one. And that brings us back to the desired state of having 3 replicas. Okay. So that's the OODA loop in practice in Kubernetes. Now let's have a look at how we can use it in security. So we might observe some current behavior, compare the current behavior with what we expected, decide whether that behavior is something we want to allow, and if it isn't, we might do something. Maybe we're going to trigger an alert or delete resources or something like that. We're going to base that on detecting anomalous behavior. Now, because we're using containers, it's actually relatively straightforward to detect unexpected behavior, or at least it's easy enough to say, this is what I expect my container to do, and see whether or not, because containers usually do one thing, we can see whether or not containers are actually doing that thing. So here's an example. I'm going to trace out the executables that run inside new containers. And I've got my Nginx deployment with 3 pods, and I'm going to delete one of those pods. And as we've already seen, the controller is going to recreate a new Nginx pod. And what we see in my tracing tool is a pause container, which is a detail, and we see Nginx running. And that is exactly the executable we expect from an Nginx pod. All right, hands up if you have ever downloaded some YAML from the internet. I think probably most of us have done that. And there's always a danger that if you don't look at the YAML very carefully, maybe it's going to do something that you didn't really expect it to do. I've made an example here where I've created, or let's pretend I've downloaded, a bad Nginx deployment. And we can see, using that same tracing tool, that it's not running Nginx. Instead, it's running some kind of bad script. So if we looked at the logs for one of those bad Nginx pods, we'll see what it's done. Now, I wrote this example myself. All I've done is print out some message. But imagine if that was a real attacker who'd persuaded me to download some bad YAML from the internet. This could be exfiltrating data, it could be exploring my network connections. This could be bad things happening. So perhaps we can observe these executables and use this for security purposes. So we could check the executable name, decide whether it's something we want to allow to run, and what are we going to do about it? Well, I'm going to do an example where I'm going to kill the pod. So I've used exactly the same tool as before, and I'm comparing the executable name with the word bad. And if it is bad, it's going to run a simple script that's going to get the list of pods, and then, just for simplicity, it's going to delete all the running pods. So that works in terms of detecting my bad script. We can see it killed all the pods. They all got deleted. And if we looked at the logs, we can see, unfortunately, that those bad pods, I've paused it at this point, we can see that those bad pods were able to print out that message. And if I carry on with this demo here, we see some error logs because you can't get logs from a container while it's being recreated or being destroyed. But we also see, basically, these pods are being deleted, recreating, and then they're doing that bad action. So the problem is that it takes time to react to this observation, and bad things could be happening during that time. If we're going to use the OODA loop for security, we need to be faster than the attacker. And in fact, John Boyd, who invented the OODA loop, said, in order to win, we have to operate faster than our adversaries. How fast is fast enough? Well, it depends on the attack. Another issue in that very naive security tool that I just showed you is that it's in conflict with that Kubernetes reconciliation loop. So if we keep deleting pods, the reconciliation loop in the controller will keep recreating them. So we're just going to keep cycling around creating and deleting pods. Maybe the security tool would need to do something more sophisticated. If it deletes the whole deployment, we end up losing a service. So maybe that's not a good solution either. It's a difficult problem. Reacting to these events is really difficult, and it would be much better if we could prevent these bad actions rather than cure them after they've happened. So a better security OODA loop would look at the intention rather than the actual behavior. And then based on the intention, it could decide whether this is something we should allow or block. Now, it's quite difficult to detect that intention at runtime, but we have other opportunities. If we look at the deployment pipeline, and this is a very simple version of it, I've been talking about reacting to anomalies at runtime, but we have other opportunities by inserting security tools earlier in that pipeline. We can do security at deploy time. We can even do security at build time. And if we do this, it's before the software ever gets to run, so we prevent security issues rather than trying to cure them. Those preventative measures, just in a little bit more detail, you can scan images at build time, and there are plenty of open source tools that will let you do that. And you can prevent those bad images. If you fail the build, you can prevent those images from being stored in a registry, and then they can never be run. We can use role-based access control that's built into Kubernetes to prevent unauthorized users from deploying code. And we can use admission controllers or the open policy agent to perform checks on that YAML to make sure that what we're deploying is what we expect and intentional. So we have a lot of options for preventative security. Now, there's runtime security and these build and deploy time security measures. And we can think of them a little bit like, locks on your house, access controls, or surveillance, runtime observation. If you were securing your house, you'd probably put the padlock on the house before you invested in a surveillance system, right? And the same should be true for the security that you put into your cloud-native deployments. If you can do both, that's great. That's a layered approach. But prioritize the access controls, prioritize the lock over the surveillance system. Prevention is always better than cure. Thank you very much.